our co-authors.
Hello, everyone. Thank you for waking up this early and coming to this session. This work is called Extending a Reactive Expression Language with Data Update Actions for End-User Application Authoring, quite a mouthful, by Leah Verou, which is me, Tarfah Alrashed, who's sitting in the third row, and David Karger. We're all from MIT. So it all started 2 years ago at UIST 2016 when we presented our work, Mavo. Mavo is an HTML language extension that makes creating web applications as easy as writing HTML. Let me demonstrate with an example. So let's take this static HTML mockup of a to-do list. And with Mavo, we can add a few annotations and turn it into a fully fledged to-do list application. You can see that we can add items, remove items, mark them as done, and so on. Everything you could expect from a simple to-do list. So how is this done? This is the markup for the static HTML mockup. This is the markup with Mavo. I'm highlighting the changed parts here. So with Mavo, you name the editable elements with the property attribute. You use the MV multiple attribute to indicate collections. From the structure of the properties, Mavo infers the schema. And there's also reactive expressions denoted by brackets. You can see two here, which are like spreadsheet expressions, but with property names instead of obscure cell references. Mavo is currently implemented as a JavaScript and CSS library. It can be dropped onto any page, and it enables HTML, and it enables its syntax by just including these two files. There's also an online playground. So how many of you have seen the website todomvc.com? Quite a few. So this is a website that implements the same to-do list with every MVC framework that exists for JavaScript. And we always wanted to participate in that directory, even though Mavo is not a JavaScript framework exactly, because all of these to-do lists are implemented with hundreds of lines of JavaScript. And if we participated with Mavo, it would have 0 lines of JavaScript, right? Which would be quite amazing. And Mavo can't actually implement most of this to-do list, except this one small thing, the clear completed functionality. So we were thinking so much about this that it actually became like an inside joke, the clear completed problem, we called it. But of course, it's not limited to clear completed. We kept finding more and more use cases. We kept seeing them everywhere. I mean, I probably don't need to convince you that programmatic data updates are needed when you're creating web applications, right? So we kept thinking, how can we add a sufficiently general syntax to Mavo to address all these use cases? And the problem extends beyond Mavo. There's thousands of questions about how to do similar things in spreadsheets. And people are just directed to using macros and Visual Basic, which is pretty much as hard as programming. So even though the work today focuses on doing this in Mavo for a number of reasons, most of this work actually applies way beyond Mavo. And a similar syntax could be applied to spreadsheets as well. So what we ended up doing was we defined a new attribute, MVAction, whose value is an expression. It uses the same expression syntax as the rest of Mavo, but we extended it to allow for multiple function calls. And unlike other Mavo expressions which are reactively evaluated, expressions in MVAction are only evaluated when the control is triggered, usually by clicking. Mavo expressions are side effect free, which is kind of not very useful in this case because side effects are all we want. So we also defined 4 data mutation functions which are only available within MVAction expressions. These are set, which is analogous to SQL's update statements, delete, which accepts any number of references, add, which is analogous to SQL's insert statements and also accepts optional initial data or a position, and move for moving items either between collections or within the same collection to a different place. We kept these functions minimal to delegate selection and filtering logic to Mavo expressions. This maximizes the amount of computation specified in a reactive fashion. We also added a where operator to facilitate filtering. So you might be thinking that this syntax seems a bit too simple, it's a little too minimal, but it becomes much more powerful when combined with Mavo's referencing scheme. So let's take a look at this simple application, which is similar to what we showed our user study participants. It has 2 collections, men and women. The inferred schema looks like this. And so Mavo has this thing where you can refer to every property anywhere in the data tree, and depending on the placement of the expression, the meaning of the property changes. So if I use an expression that outputs age here, and yes, this is a live demo, it's not a video or anything. If I use an age expression here, you can see that it prints out the age of the current person. However, if I move this expression outside both collections, notice that now it prints all of the ages, which is useful because when I'm outside the collection, it's usually things like average age that I want to do, which just works. Similarly, with the nested collection called hobby, it just gives me all the people's hobbies. Whereas if I do this inside each item, it gives me just the current person's hobbies. And it turns out that in most cases, this is actually what people expect. And this extends to data actions as well. Let's try adding one. So I'm going to add an action here that increments the current age. I'm going to call it oldify. So if I press it here, notice that because it's within each item and age refers to the current age, it's only incrementing the age of the current person. However, if I move it outside both collections, it increments the age of everyone. So basically, based on where I put the control that triggers the action, the meaning of the action, Mavo tries to infer what the meaning of the action is, and in most cases it seems to get it right. Let's look at some use cases. Of course, before every other use case is the clear completed one, which now can be implemented with just a simple, intuitive one-line expression. This is a word game from our user study. You might remember it from the cover. The user clicks on words to put them in and tries to guess the right order, which is useful when you're learning a language. You might have seen it in language learning applications. The first action, when you click on words, it copies the current word into the ordered word collection. Undo just deletes the last ordered word item. Marking whether the sentence is correct is just a typical reactive Mavo application. And deleting all items, the clear button, is implemented by just deleting all ordered word items. This is a shopping list also from our user study. It has a list of items to buy and a list of common items that we buy often. The plus common items button copies the current item into the common items collection, and clicking on common items copies them into the shopping list. This dice roller is also from our user study. We'll talk about it a little bit at the end as well. It's one of the few examples where the required action has two function calls. One to add the current dice to the dice history, and one to set it to a random number between 1 and 6. This is the lottery we use to raffle Amazon gift cards to compensate our participants. Of course, it's made with Mavo as well. The draw button shuffles the list and picks the first 2 winners, or however many we have, and sets the winner collection to that. And the clear button just deletes all items from both collections. Clicking on this map inserts items to the event collection and prefills the latitude and longitude based on the mouse position, which also positions the new item. And for lastly, this fully functional eShop, where most of it was already possible with Mavo, but Mavo actions, data actions enabled us to finish its functionality, like an add to cart button, which is quite basic in an eShop. And the add to cart button just copies the current item into the cart, the product collection in the cart application, which is a separate application because it's stored locally. And it's implemented with PayPal's HTML API, so it has a fully functional checkout, as you can see. So, of course, we did a user study. The research questions we tried to answer was twofold. The first one was, can novices actually use data actions? And also, what is the most natural syntax for them? Now, usually, people do either a natural programming elicitation study or a study where they test a prototype. We decided to do a hybrid so that we could also see how people's answers compare. So we recruited 20 participants from local meetup groups about CSS or HTML, of varied demographics, and they were all intermediate or below in programming skill, self-reported. The study design, as I mentioned, was hybrid. There was an unconstrained elicitation part, where people were answering 17 questions based on what's the most natural syntax for them. We only told them the fewest things that we could possibly tell them about what we're trying to do. Then we explained our prototype syntax, and they had to answer the same questions again. And lastly, there were hands-on tasks as well to see how well they do when they can iterate. These were the 17 questions that they had to answer in the elicitation. Obviously, I don't expect you to read all of them. That's a lot of questions. But just to get an idea of what kind of questions we asked. So, for the first part, the elicitation, remember that I mentioned that in Mavo you can reference any property from anywhere, and depending on the placement of the expression, that's what determines its value. We call this implicit referencing, and all participants used implicit referencing for all items and the current item, most of them for the current item. However, some participants felt that they needed an extra keyword, like an all keyword to refer to all items, or a current keyword to refer to the current item. We call this explicit referencing. We noticed that none of the participants that used explicit referencing did so consistently. They used both implicit and explicit referencing, sometimes multiple different kinds within the same expression, just in different arguments. This may indicate that implicit referencing actually does minimize error conditions, but explicit referencing can still be useful for novices that prefer a more verbose way of referencing things. Something we saw a lot was underspecified expressions that were missing required information. While this at first may seem as faulty logic, in most cases, participants seem to have a clever heuristic in mind about how these would work. By far, the most common one of these was delete with just the predicate passed in, without any mention of what would be deleted. 18 out of 20 subjects did this. Perhaps we could accommodate by defaulting to the closest item if only a predicate is passed. Also setting age +1 to increment without a mention of what we're setting. 15 out of 20 subjects did this. No one underspecified set expressions when the property they were setting was different than the property they were reading. So perhaps this indicates a distaste of repetition, which is also seen in natural language. Perhaps in the future we could default to the first name token if only one argument is passed. Something that was also slightly common was using name as an implied primary key, as if it has some sort of special meaning, which also is similar to how natural language works. We don't say the person with the name of Chris, we say Chris. And using objects as numbers, which is also seen by other studies in the literature, like doing mathematical operations on entire objects instead of using their properties. Some participants mentioned that they expected this to just operate on the first numerical property, which is an interesting heuristic. While commas for argument separation are quite common in programming languages, they were not that natural to our subjects. 7 used no commas at all. 5 only used commas for repetition of the same argument type. 6 combined commas with other argument separators, and only 2 used commas in the way that they're used in programming languages. So what separators did people actually use then? The equal sign was the most common one for set primarily, but also for initial data in add, as you can see in the last row. Commas were still relatively popular, with 13 people using them at least once. Keywords like to in set or move, and spaces and colons were also used. Perhaps in the future we can allow a to keyword, which also makes it read more naturally. And perhaps we should even special case the equality operator in set to accommodate for this kind of pattern, since 16 people out of 20 used it. Even though we extended Mavo's expression language to support multiple function calls, only 8 participants were actually used something like this. 12 tried to express compound actions via arguments, even when this was inconsistent with their later responses. Some of their answers during the elicitation part were actually consistent with our prototype syntax, which we found interesting. It's not many, but given that they had never seen it, it's quite interesting. So for the prototype syntax, remember they had to answer the same questions in the same order, but this time using our syntax. Some of the very prominent patterns from the previous part also persisted, but at a much lower rate. These are the correctness rates of all questions. Since this is not elicitation anymore, we can actually calculate the correctness rate. And these are the questions in the order asked, but let's order them by correctness. So we can see here that while most of them have a correctness rate of 75% or above, some of them are significantly lower. So let's see what's the issue with these two. They both have the same problem. We are filtering on one property and setting another. And it seems that our syntax is not very intuitive here. Participants were able to filter correctly, they used the right function, but then they were stuck about where to put the property they're setting because it's so removed from the actual value. The other questions that had low success rates, it was because of issues I've already mentioned before, like inability to sequence function calls, trying to increment by h+1, and things like that. And lastly, for the hands-on tasks, these were all of them. You've seen all three applications. Each participant did 2 of them. Most of them had pretty high success rates, with one exception. And to understand why this happened, let's take a closer look at the dice roller. This was the state that participants were given. All they had to do was write the MV action attribute on the button. So for the first task, they had to actually roll a new random dice and set it to a number between 1 and 6. And that was easy. Everybody was able to do that. The second task, for the second task, they had to add the dice roll, they had to populate the dice history collection. They all did it by adding here, like this. And you can see that this does work, but the current dice is also the last item. So the third task, they did this even though our question was carefully worded in a way to not imply any specific order, but they all put the add statement, the add function call last. So for the third task, they had to prevent the current dice from showing up in the history. And all they needed to do was just reverse the order of these 2 functions. And now it works. However, only 1 out of 8 was able to do that, which could be because of 2 reasons. Maybe because this is very different from the declarative paradigm that we've been teaching them so far. They need to simulate the order of operations. Or it could be because imperative thinking is just generally hard. In similar studies, it seems that some novices are under the impression that function calls are somehow executed in parallel, but we noticed that even participants that were fully aware that they are executed in sequence, they were still not able to do this. The overall reactions ranged from positive to enthusiastic. People found data actions useful and approachable, even those that made a lot of mistakes. So, as conclusions, novices do seem to be able to formulate data actions and find them useful. Of course, there's a lot of room for improvement in terms of the syntax. It seems that syntax rigidity is not natural. Perhaps the solution is more sloppiness in programming languages. And repetition also doesn't seem to be natural. We're not familiar with repetition in natural language, so perhaps we need more heuristics. So thank you very much, and I'm not sure if we have time for questions, but if we do, I'd gladly take them. We don't?
1 or 2 questions.
Oh, okay.
Okay, thank you. Yeah, so we have time for 1 or 2 questions. There are microphones in the middle and on the side. And if you come to the microphone, please state your name and affiliation. Since people are shy in the first talk in the morning, I'll get started. How did people, what were the strategies for debugging when things didn't work as expected?
Yeah, that's a very interesting question. So keep in mind that only in the last part, the hands-on task, they could actually iterate. During the elicitation, they were discouraged from either even rewriting their expression. And same with when they had to answer the same questions with the prototype syntax, it was just a survey with the 17 questions. And we discouraged them from iterating in that case. We wanted to capture their initial thinking to see what's more natural. So actually the ones that got it right there, it's basically equivalent to getting it right at first try. They could iterate in the hands-on tasks. I can't say we saw particularly sophisticated debugging techniques. They were just trying different things and seeing what happened. For example, some of them tried move instead of add. It didn't do what they expected. So they were just trying different things. What it did indicate is that it seems that we need to take extra care to produce a meaningful result, even if it's not. Even if people are using these functions in unexpected ways, it should still do something meaningful because that gives them feedback about what they did wrong. which we could certainly improve on. Like, in some cases, it was quite confusing to them.
Okay. Thank you. We're going to stop it here. So let's get the next speaker on stage, and thank you again.